संडे मूवी कॉल किया हमारे थोड़ा कॉल अभी आज
Let's what we did next chapter. Let's move to the next chapter. Sorry.
Yes.
That's all right. We had textbook. Does anyone have textbook? I am here. Anyone have answer? Yes, that's all we can read. We won't read that much, but just keep it in this awareness. The parts, force, and laws of motion. So we have finished motion. In this class, we will be doing force and laws of motion. Let me check the name. Yes, force and laws of motion. 840. Force and laws of motion, and we will start with some interesting things. We do not have it solved, right? Okay. So now let's start. And in this chapter we don't need as required. Now we studied about forces in previous grades. Do you know something about force? अभी हमने पिछले चैप्टर में क्या देखा, मोशन देखा हुआ है. फोर्स के बारे में हाँ? No, okay, let's just take it like this. So there is a body. Okay, that's the body. We know that this body as of now it is what? It is moving. No, this is at rest. Okay? If I apply some force in this direction, okay, what is SI unit of force? Do you know that? Force is measured in terms of newtons. So I'm not sure if in previous grade have you even heard about force and the units. So the force is the quantity, and we push the object. We are pushing this in this direction. So we know that because of this force, this body will move in which direction? Towards the right. Okay. So let's say this force that was applied, its value was, let's say, it was 10 newtons. How much? 10 newton force. Now, so this was me pushing this box. Okay? Now somebody else starts pushing this box from this side. Okay? Even in tug of war, you know, right? आधे लोग यहाँ से खींचते होते हैं. So there are people who pulls in this direction. There are people who pulls in what? Opposite direction, right? So you can consider this example as well. Okay? So they are pulling in this direction and this. In this case, I am talking about the box. 10 newton force was applied in this direction. It was moving, but then suddenly somebody from the opposite side came. He started applying force of 10 newton. But then in this, I am applying F1. It's applying F2. But then it was being applied in opposite direction. What will happen? The object is not going to move because how much the force that I was applying and the force this person is applying in opposite direction, they will get balanced. They will what? They get balanced. Okay. So in this case, the net force acting on this body, the net force with let's say which is F. So net force acting on this body, which is F, is given by what? It is given by F1 plus F2, the algebraic sum. Okay. We talk of the algebraic sum. So F1 by F2, if you say, oh, F1 by F2 is 10 plus 20 Newton. No, we take with the help of direction also. So if this direction is considered, positive, so if we consider this direction is positive, then this 10 Newton is which direction? Minus 10. So it will become plus 10 plus minus 10. So 10 Newton plus minus 10 Newton is equal to 0 Newton. So net force acting on this body is 0. Okay. But what if they both are applying force in the same direction? What will happen? It will again, we will follow the same thing. In this scenario, the net force is what? Net force is again given by the same formula F1 plus F2. So both of them are in same direction. It will be 10 plus 10, which is nothing but 20. Okay? Okay? Now, this is the same thing that we will be doing here. Okay? So the same thing will happen here if these people are applying 50 Newton of force in this direction. Okay? And these people are applying 50 Newton of force in this direction. Then both the sides are getting what? Balanced. We call such forces as balanced force, which is, we call it what? Balanced force. But then balanced situation agar ye to koi winning team milegi? तो हमें विनिंग टीम के लिए क्या हो जाता है, कोई एक टीम ज्यादा न्यूटन का फोर्स अप्लाई करती है. So let's say that this team was applying 70 Newton of force. So this will result in what? So all of them will be pulled in this direction. Why? Because this side is greater. ठीक है? And what is the net? यहाँ 50 था, यहाँ 70 था. What is the net force acting on the rope? 20. And which direction? That direction. So net force is how much? Let's say this is 70 and this is 50. 50 है. So 70 minus 50, which is equal to 20 Newton. Okay, so 20 Newton of forces acting, or if you write properly in terms of algebraic sum, so it will be 70 plus minus 50, which will be 20 Newton. Okay, and in this case, we see that this situation is an unbalanced force. What is this? Unbalanced force, and this unbalanced force results in what? The motion of the object. Are you getting this? This scenario is clear to you? So this is just introduction of what is balanced force and what is unbalanced force. So you can like draw this part. You can draw the same scenario over here. Right, this one F1, F2, and this is case of balanced force. And in this case, I have drawn this like this. This is just for the algebraic sum. So unbalanced force में हम यहाँ पे क्या लिख देंगे? एक यहाँ पे यही आप तवा फॉर्म मत बनाइए, हम यहीं पे बता देते हैं. So this is 50 Newton, and in this side 70 Newton force is applied. Then what will happen? The net force is given by what? This 70 plus this is in opposite direction, so minus 50, which is equal to 20 Newton, and this is case of unbalanced force. You just write these two things. Are you having the test tomorrow?
Yes, ma'am.
Which chapter is in fact? The 16th start. It is this class. Minus given some. Previous time was pretty important. This will be much more easy compared to what we did in previous time. We have first law and this of course. So this is very important from using balanced and unbalanced mechanism, balanced and unbalanced force. You will see that then this object, where is this now? Draw dotted lines, an object will move, right? Object will move in this direction. Okay. and I have, please let me know if I was making changes or made something different in this direction. So we were talking कि ये वाला direction कौन सा होगा, positive या negative?
Positive.
ये साइड में जा रहा था तो हम क्या ले रहे थे, नेगेटिव, राइट? सो ये 17 न्यूटन नेगेटिव में होना चाहिए था और ये पॉजिटिव होना चाहिए था -20. सो दैट मींस दिस बॉडी विल मूव, दिस बॉडी विल हैव नेट फोर्स ऑफ 20 न्यूटन इन विच डायरेक्शन, बैकवर्ड डायरेक्शन. आई होप यू गॉट इट. मैं डबल प्रोसेस सीधा यहाँ पे तो मैंने भी दिस. So you see that when there is balance force acting on a body, we don't see any change in the position of the object. The body is not moving, ठीक है? And when there is unbalanced force, we see that this body starts moving. Okay. Now even, are we done? So we conclude one very important thing, that this unbalanced force will result in what? It will result in motion of the body. Okay, but if this body was already moving, let's say it was moving, then if I am applying some extra force, then again it can increase the speed of the body, or it can contribute in the change in direction also. So we say that unbalanced force can result in, how we will again see, it will result in either change, there will be some change in motion, there will be some change in motion. If this was already moving and 70 Newton is applied, then maybe this moving body can stop and start going backward. So if it starts going backward, I will see change in direction. Are you getting what I am trying to say? If this body was already moving due to this force 50 Newton, तो ये move हो रहा था, right? फिर जब मैंने ये 70 Newton apply कर दिया, तो क्या हो गया? I saw that it actually was changes in direction, and of course there is change in motion also, right? Okay? So this unbalanced force can either result in this or both. Okay? So there is unbalanced force required. Okay? And Newton was the first person, he actually showed it. It did a very good experimental part. So very interesting. It's very interesting to understand also, realize how he must have come across those thoughts. Like, it is not that easy. This one is even more interesting. How we came with this first law of motion. What he realized, he gave an example of a body with inclined surface. Oh, I'm so sorry. Newton's 3 laws of motion are there, but first law of Newton was put forward in a beautiful way by this experiment which Galileo's performed. Not experiment, that he has put forward this way in which he concluded that okay, that is how it works. The first law of Newton works. So let's go to that. So what is an experiment? So there is this object. This is an inclined surface. This body is moving down. Okay, this body is falling down. So this is by Galileo. Thank you so much. Galileo who came up with this. Okay, नीचे की तरफ जाएगा. ठीक है? He says that if this particular thing, surface, both the surfaces are extremely smooth, that means there is no friction. आपको पता है friction क्या करता है? Friction क्या करता है? It stops the jam quality. हाँ, अगर ये यहाँ पे मेरा केस था, यहाँ पे एक केस था जहाँ पे मैं कितना फोर्स अप्लाई कर रही थी, 50 न्यूटन in this direction, right? Friction क्या करता है? हमेशा opposite direction में फोर्स अप्लाई करता है। सो हम फ्रिक्शन का काम क्या होता है, इसी बॉडी पे ऑपोजिट डायरेक्शन में फोर्स अप्लाई करता है, एंड दैट इज हाउ इट ट्राइज टू स्टॉप द बॉडी फ्रॉम मूविंग, राइट? सो Galileo said that this is perfectly smooth surface, perfectly smooth. So there is no friction. Friction नहीं कर रहा है, friction happening नहीं कर रहा है, friction happening नहीं कर रहा है. So ideal cases when there is no friction, ऐसा कुछ नहीं. So what will happen if मैं ये inclined surface को exactly इसी के opposite पे inclined surface में कर दूं, then this particular object should go down and reach the same height from where it came. So ये height जो है यहाँ से, it should go on and reach the same height. ठीक है, that is what he proposed, and that too in very interesting way. So ideal case में क्या होता है, अगर कुछ friction या कुछ overcoming नहीं करना है, तो यहाँ से जाकर यहाँ पे पहुंच जाना चाहिए. Ideal best scenario, there is no friction. But what changes does it do? But what if this inclined plane, if he says that if this incline is थोड़ा बहुत incline जो है थोड़ा कम कर दिया, ठीक है? So what this object which has come down and which will go up, आपको भी पता है अगर कोई आपका inclined plane होता है, आपको बॉल नीचे जाता है, यहाँ आने के बाद तुरंत थोड़ी ना जाता है, रुक जाता है, no right? वो आगे जाएगा, डिपेंड करेगा, किस पे डिपेंड करता है कितना आगे जाएगा, यहाँ का सरफेस कैसा है, राइट? अगर बहुत खराब है तो थोड़े टाइम के बाद ही रुक जाता है, अगर काफी अच्छा स्मूथ है शायद और आगे जाकर रुक जाएगा, राइट? एंड यहाँ पे अगर थोड़ा आप अगर ऐसे भी कर दो तो डिपेंडिंग अपॉन आपको कौन से हाइट से आ रहा है उतना ऊपर जाता है, राइट? स्केटर्स एंड ऑल दे आर परफॉर्मिंग ऑल दिस. सो इन हिज केस ही सेड दिस इज frictionless surface, there is no friction, both of them are very smooth, then it should reach back to its original height it has come from. But if I try to go slightly, I just reduce the slope, then what this thing will do, this thing will keep on moving until it reaches the same height. यहाँ पे उसकी हाइट जो थी, चेंज इन हाइट जो थी वो यहाँ पे आ जाएगा. बेसिकली यहाँ से जितनी एनर्जी थी उसके पास नीचे गिरने के लिए, फिर से वही एनर्जी में आ जाएगा, बिकॉज एनर्जी का लॉ ऑफ कंजर्वेशन है, दैट एनर्जी इज ऑलवेज कन्वर्टेड, यू कांट क्रिएट और डिस्ट्रॉय एनर्जी. ठीक है, सो ही सेड इट विल गो एंड मूव अप, बट इफ आई रिड्यूस द इंक्लाइन देन दिस विल मूव further longer distance to reach the same height. If I reduce even more, then it will try even more to reach the same height. What he's trying to say that the same ball will travel longer distance to reach this position. If I reduce the height and decrease on the slope, this will again travel more length to reach the same height. He said, if you keep on doing this, so the same thing, if you started from the same position, it will keep on moving until it reaches back its original state of position. Are you ready? And he said, if you make this perfectly horizontal, if you make this perfectly horizontal, it's very important. If you make this perfectly horizontal, he said, this body, what will it do? Tell me. It will go on forever and ever for search of what? Reaching this position, right? It should continue to move in its position, okay, in that direction to reach where it has started from. What did this mean? He showed it. Newton's first law said that object एक जो होता है, and I'm erasing this. एक ऑब्जेक्ट जो होता है, ठीक है, ऑब्जेक्ट ये रेस्ट पे है तो रेस्ट पे ही रहेगा. न्यूटन से आपको भी पता है ये रेस्ट पे तो रेस्ट पे ही रहेगा. इसको ये रेस्ट का इसका स्टेट ऑफ मोशन है. इसका स्टेट ऑफ मोशन क्या? स्टेट ऑफ मोशन इज of motion. So this particular object is in the state of rest. If I want to change its state, what do? I have to apply some external force. खुद से तो ये move नहीं होने वाला. Agreed? Right? So that's what Newton said, that it will continue to be in its state of rest until you apply some external force to this. So until external force is applied, this body will continue to be in its state of rest. Okay? But what if this was already moving? So this body was already moving. Okay? What happened? What if this body was already moving? So this body should continue that state of motion. That's what will happen in ideal case. This body will continue. This body will continue its state of motion. It will continue its state of motion. Until it is acted upon by what? An external force. Okay? So if it is moving, it will keep on moving. And if you want to make it stop, you have to what? Apply some external force. Basically, you have to apply your muscular force to stop it. And if you want to speed up this motion, which it was going, if it was going with velocity, and if you want to speed up, then again you have to apply force. Okay? If you apply it in this direction, then it will speed up and go. If you apply force from opposite side, then it might stop. And if you apply more force, it might go in the reverse direction. Okay? This thing, this is Newton's first law of motion. What is the first law of motion? Then a body will continue to be in its state of rest or state of motion until an external force is applied on it. Okay? External forces applied on it. And this Galileo showed it via this. So what is happening? This body, it starts to incline plane. So why this whole thing came? Because there was a question that why this body will continue its state of motion if nothing is happening. Say why will it continue its state of motion? Basically, जितने space का move जाएगा. So this thing he explained. Why will it happen? If it has come from something, it has received that energy with it, and it will continue until it reaches from where it came from. Are you getting? So this is the famous Galileo's equation for. So it is. So this is the most important thing, and this has its relation with the first law of motion. So first, Newton's first law of motion. So write this, okay? And then when wordings will put, if you want to put this diagram, you can put it. So it goes like this and it will stop. So this should be same. Okay, let's just see this like this. So again, so it will stop after reaching this position. Okay? And then it will travel this much extra path, reach. So this will continue forever in the horizontal plane. It will continue forever until when will this stop? So this it has fallen down and this will continue to move. And when will this change over here? Will we change? No, but when अगर कुछ external force apply कर दे तो ये रुक जाएगा या फिर से return कर जाएगा. So that is there. I see there is some other bodies in which they are getting. Yeah, not have objects. Yeah. Okay, are we done? So if you are done with this, we'll put the first law in verdicts. Okay. So this experiment. So what Galileo did, he just said that okay, when you are doing this particular thing will keep on moving, keep on moving, keep on moving forever. You can put it in terms of laws. Now I already told you what is the law. That an extra, sorry, what was that? A body, will put it in words. You also help me out. A body will continue to be in what state of rest or its state of motion until an external force acts, right? So, until an external force acts. Now, in the previous case, what did we study? अभी just थोड़ी पहले हमने क्या पढ़ा? Balance and unbalance force. ठीक है? So अब ये body ऐसे जा रहा था. ये body जा रहा है ऐसे. अगर यहाँ पे ये already let me just use red color. So this body was moving. It was already moving. ठीक है? Now external forces act on them. ठीक है? One external force act like this 5 Newton. And one external force act like this 5 Newton. ठीक है? Will you see any change in its state of motion? Why? What will stop? Okay. Will the object stop? Think and tell me. He's saying object will stop. Will object stop? Did you hear the scenario first? So this object was already moving. I just depicted it was moving. This black color shows that it was moving with that particular velocity. It was moving. Okay. Then on that moving object, I apply force in this direction of 5 Newton. He applies force of 5 Newton in opposite direction. Okay? Will this object stop or continue in its state, or what will happen to this object? Did you get the question? Did you get the question? ठीक है? बताइए क्या होगा? मुझे ये बताइए it will not move. अब मुझे ये बताइए इस केस में एक्सटर्नल फोर्सेस दो एक्ट हुए हैं, ठीक है? एक्सटर्नल फोर्स जो एक्ट हुए ना उसका नेट कितना है, नेट इफेक्ट कितना है? 0 था. बाहर के जो फोर्सेस एक्ट हुए थे उसने इसने 5 न्यूटन ऐसे दिया था, इसने 5 न्यूटन पीछे की तरफ था. इसका अलजेब्रिक सम कितना है? 0 है. ठीक है? इन दोनों ने मिलकर इस ऑब्जेक्ट पे कुछ काम किया है? Yes or no? No, right? No. If these two external forces could not do any work on this, okay, then this object should continue what it was doing before. Agreeing with me? Agreeing with me? So ये ऐसे जो दो equal forces external act हुए, ऐसे forces को क्या बोलते हैं? Balance force. ठीक है. सो बेसिकली जो आप एक्सटर्नल फोर्स लगा रहे हैं ना, उसमें भी एक एक्स्ट्रा रिक्वायरमेंट है कि आप जो एक्सटर्नल फोर्सेस लगाते हो वो कैसा होना चाहिए, बैलेंस ना कि अनबैलेंस्ड होना चाहिए, अनबैलेंस्ड होना चाहिए ना. ठीक है. सो इट शुड बी एक्सटर्नल unbalanced force. Are you getting what I am trying to say? Now, why I am putting it right now? Because now we are going to put the law and we have to be very accurate in terms of what we are writing. So how do we now write the first law of motion? That an object will continue to be in its state of rest. I hope you understood this. Why we have to add this extra unbalanced word? Because the force that is एक्सटर्नल फोर्स जो होना चाहिए वो अनबैलेंस्ड होना चाहिए. 7 और 5 होगा तो शायद इफेक्ट कुछ चेंज दिखेगा, यहाँ पे 5 और थोड़ी स्पीड बढ़ जाएगी. ठीक है. और अगर 5 है और यहाँ पे 7 है तो यहाँ की तरफ थोड़ा रेजिस्टेंस होगा. बट आपने दोनों 5 5 दे दिया तो बाहर वाले में तो कुछ काम ही नहीं किया, ये जो अपना कर रहा है वो करता रहे. ठीक है. सो दैट इज व्हाई वी ऐड अनदर वर्ड कि एक्सटर्नल unbalanced forces to practice. Shall I tell the law now? So, a body will continue to be in its state of rest. A body will continue to be in its state of rest or state of motion until तब तक जब तक हम पढ़े एक्सटर्नल, until an external unbalanced force is either acted upon it or applied on it. An external unbalanced force is acted upon it or is applied on it. We do not have any questions to begin with. We'll just now start the second one. So what she was asking me with respect to first law, so you got this is the first law, which we get from this. We conclude from this one. There is another important thing that we see over here. जब हम बोल रहे हैं कि these these bodies will continue to do what they were doing. ठीक है. In other words, we are saying कि they are resisting a change, right? What they don't want to change, तो सारे वही करते जा रहे हैं, right? They are resisting change. This is inherent property there. They want to continue either whatever state they are in, be it rest, be it motion. That is called inertia. That is called what? Inertia. So inertia is a new concept, okay, which we get from the first law. How do we experience it? Most of the time, every day we go through this inertia experiment. Inertia experiment experience, and the very easiest example for you to understand is the jerks that you get when you are in bus or train. ठीक है. आप बैठे हुए हो, ठीक है, या तो आपकी गाड़ी जो है आपकी चल रही है, आपकी गाड़ी चल रही है, अब गाड़ी की जो स्पीड है आप भी वही मोशन में जा रहे हो. ठीक है. आप भी वही स्पीड से आपकी जो बॉडी है वो मूव हो रही है, लेट्स से वो आपके जो मोशन है वो विद वेलोसिटी दी जा रही है. एंड जब मोशन की वेलोसिटी सेम है तो कौन सा मोशन बोलते हैं? It did it in last class. When a body is moving with same speed, because here it continues to be in same speed से move हो रहा है, कुछ change नहीं हो रहा है, so we call it what kind of motion? Uniform motion. Remember? We call it uniform motion. So if this we are moving with that bus, ठीक है, and let's say we are moving with that uniform velocity, हमारा body carry कर रहा है uniform motion. We are in uniform motion. अचानक से गाड़ी को ब्रेक लगता है. क्या होगा? अचानक से गाड़ी को ब्रेक लगता है. So जब I have reached this position, ठीक है, when brake is applied, what will happen? क्या होता है अक्सर जब ब्रेक लगता है तो हम ऐसे गाड़ी मूव करते हैं, जब ब्रेक लगता है तो आपकी बॉडी कहाँ आगे की तरफ झुकता है। Why what happens that गाड़ी को जब ब्रेक लगता है तो आपका जो अपर पोर्शन होता है, आपका एक्चुअली पूरा बॉडी ही जो है इट वाज हैविंग अ फीलिंग दैट हम पोर्शन में जा रहे हैं, आगे फॉरवर्ड के डायरेक्शन में जा रहे हैं, बट सिंस गाड़ी हमारी बॉडी जो है गाड़ी से जुड़ी हुई है, एज गाड़ी रुक जाती है आपका लोअर पोर्शन तो रुक जाता है जल्दी से, बट उसके कारण से हमारा आगे का बॉडी क्या जाता है थोड़ा टाइम ले लेता है। हमें लग रहा है कि unconscious state of motion से चलता है आगे का, ठीक है। So we slightly go ahead because of this tendency to continue a state of motion. So we go slightly ahead and then गाड़ी रुक जाते हैं तो बॉडी आपका पीछे रहेगा तो आप थोड़ी ना आगे बॉडी स्ट्रेट करते हैं, तो फिर आप क्या जाते हैं आप फिर जर्क होता है। So this is what inertia is what आपकी बॉडी को टेंडेंसी है जो स्टेट पे हो वो रहने की। और इसमें आपको कौन सी टेंडेंसी थी, आपको क्या कंटिन्यू करने का ये था बॉडी को, इनर्शिया ऑफ मोशन था कि आपका जो मोशन है आप वही कंटिन्यू करने का बॉडी को टेंडेंसी था। सो दैट टेंडेंसी इज कॉल्ड, सो दैट इज इनर्शिया। सो दिस वाज इनर्शिया ऑफ मोशन का एग्जांपल, ठीक है, दिस वाज इनर्शिया ऑफ मोशन का एग्जांपल। हम फिर से करेंगे definition में लिख लेंगे, that is what is called as, so this, but you understood what is inertia of motion, right? Similarly there is one inertia of rest. Inertia of rest, they are given a beautiful examples। ये जो झाड़ियां होती है उसकी पत्तियां हम vigorously हिलाएंगे, ठीक है, vigorously हिलाएंगे तो पत्तियां क्या हो जाती है, टूट जाती है, ठीक है। For that again the example is for inertia of rest. So when Pattiya was here, it was quite here. What happens when you try to shake it? So आप क्या कर रहे हो, ये पूरी पत्ती को आप उसकी पोजीशन से डिस्प्लेस कर रहे हो, but then this पत्ती will try to remain in its original position where it was state of rest, ठीक है। So lower portion goes, but this जहाँ पे वो attach होती है it will try कि वो जहाँ थी वहां ही रहे, और इसकी वजह से क्या हो जाता है, एक जो है टेंडेंसी यहाँ पिछले जगह पे रहने की कोशिश कर रहा है। So this is your डाली and this is your leaf, ठीक है। So what will happen, this leaf को swing मिला तो it will go, but then this at this point of contact this has tendency toward to stay at this position where it was. So there will be what, two way at this particular junction, this whole thing is trying to take it away in this direction, and due to inertia of rest this is trying to stay back, and जब आपके यहाँ पे जंक्शन पे दो ऑपोजिट डायरेक्शन में काम हो रहा है, और अगर ये बहुत डेलिकेट पत्ते, नॉट एवरी पत्ती स्टार्ट्स फॉलिंग एंड ट्री बिकम्स लीव्स, इसके बिना ऐसा तो नहीं होता, बट जो पत्ती काफी थिन है उसका पॉइंट ऑफ कांटेक्ट तो काफी थिनली अटैच्ड है, व्हाट विल हैपन, इट विल व्हाट इजीली ब्रेक अवे, राइट, इट विल इजीली ब्रेक अवे। सो यहाँ पे ये जो ब्रेक अवे हो जा रहा है, ठीक है, दैट इज आल्सो व्हाट इनर्शिया ऑफ लीव्स, ठीक है। सो बिकॉज़ ऑफ इनर्शिया ऑफ लीव्स देन यू शेक, ये टू पे जो ये हो रहा है, टू जो फोर्सेस एक्ट हो रहे हैं और वो लीव्स विल रिजल्ट इन व्हाट, कि पत्तियां गिर जा रही है। एंड आप जब कैरम खेलते हो, आई डोंट नो, हैव यू प्लेड कैरम, and you know that you know आप ऐसे स्टैक होता है, ठीक है, कई बार आपने देखा होगा कि जब एक स्ट्राइकर मान लीजिए नीचे वाले को से स्ट्राइक किया है और बहुत स्पीड में हुआ ये प्रोसेस, तो ये क्या हो जाता है, ये सारा ऑफकोर्स कभी कभार सारा भी गिरता है, बट कभी कभार जब ये बहुत फास्ट होता है, सो दिस स्ट्राइकर गोस, नॉट स्ट्राइकर हिट करके जो नीचे, what do you call it, coins, right? So this coin, the lowermost coin will move, but these things na they will shift downwards. Why? Because इनके ये क्या थी, ये रेस्ट पे थी ऊपर इनर्शिया में, so they will continue their state of rest, ठीक है, and they won't go away, they will continue their state of rest. This is gone, ये state of rest ग्रेविटी की वजह से शिफ्ट किया जाता है, नीचे शिफ्ट होते हैं, इनका state of rest था तो state of rest ही रहता है। Are you getting what I am trying to say over here? You are Okay, so this is inertia. Inertia is nothing but the thing will be there from the first one. That is the tendency of the body. It is the tendency of the body to continue its state of rest or state of motion. Okay, it is resisting any change. Okay, so take inertia definition. The natural tendency of any object, or if it's not any body, the natural tendency of a body or of an object to what? To resist, to resist, to resist to resist any change, to resist any change. Actually, I'm not very fast. To resist any change. What is it resisting? क्या change को resist कर रहा है? Either state of rest to resist any change in its state of rest or in its state of motion. Okay? To resist any change in its state of rest. So either state of rest में resistance है या in its state of motion. How much time do we have? 45 minutes. Second one is very important. So the first law is that, and from first law, we come across the property of inertia of a body. Okay. Now we'll move to second law, the most important law of Newton's. It is the most important law of Newton. Second law. It is Newton's second law of motion. This one from the inertia. Once we are done this tell me to jump back to inertia. Just tell me factors on which it depends. Newton's second law of motion. Newton's second law of motion पे जाने के पहले we'll know what is this. Are we aware of the term called momentum? So a body, an object हम जिसकी बात कर रहे हैं, every object will have mass. ठीक है, it will have mass. So momentum of any object, okay, it is represented by letter small p, ठीक है, and it is given by product of mass of that body and the velocity with which it is moving. So basically, we can say it is given by mp. What is momentum? Momentum of any body is what? Mass and the velocity with which it is moving. Okay. So if I ask you what is momentum of a body of this duster, what is momentum of this duster? What would you tell me? Mass. I'm asking you what is momentum of this duster. So आप क्या करोगे? Mass of this duster multiplied by velocity of this duster. Can you tell me comment about the velocity of this duster? Zero है. So आपका overall momentum of this duster क्या हो जाएगा? Irrespective of whether उसका mass तो कुछ होगा, let's say 50 ग्राम, 100 ग्राम, ठीक है? 200 ग्राम. Velocity क्या है duster का? Zero. So momentum that it is carrying is what? Zero. ठीक है? So that is what is momentum? Momentum is product of mass and velocity of a body. ठीक है? And first say what is SI unit of momentum? So we all know SI units of SI unit of, so we all know what is SI unit of mass. What is SI unit for mass? Mass. ग्राम में हम करते हैं. This is the SI unit of measurement mass. So SI unit of momentum is what? Meter per second. Okay? That is SI unit for momentum. This is the game of the momentum of any body is given by it is the product of mass and its velocity. Newton's stated this body is at rest. What do you have to? This body is at rest. Agreed? ठीक है? अब ये बॉडी रेस्ट में है, तो इसका कुछ मोमेंटम है. अब मुझे जो इसका स्टेट ऑफ रेस्ट है ना, उसको चेंज करना है, मुझे इसे मूव करना है. सो व्हाट विल आई अप्लाई? एक्सटर्नल फोर्स. कैसा होना चाहिए वो? अनबैलेंस. अब तो स्पेसिफिक वर्ड्स में यूज करेंगे आप थोड़ा और डिटेल. सो आई एम अप्लाइंग एक्सटर्नल अनबैलेंस्ड फोर्स. ठीक है? That force will result in what? Motion of this body. ठीक है? So अगर इसकी ये मास था, इसकी पहले वेलोसिटी क्या थी? कुछ तो इनिशियल वेलोसिटी थी. अब जब ये मूव होने लग गई, तो it will move with some the same body of the same mass will start moving with some velocity. Are you getting right? Are you getting what I am trying to say? Okay? So now इसका पहले का मोमेंटम क्या था? m into रेस्ट पे था इसलिए 0 था. अब इसका मोमेंटम क्या हो गया है? m into v. And what I definitely see that there is what change in the momentum value. Okay, I see change in momentum. Newton's second law state that is change in momentum. Okay, the change in momentum. This change in momentum is due to what some external force that we are applying, and they are related to some extent. They are related in the direction. That is how it's. So he says that if you apply more external balance force, then you know this value of V will what? Increase or decrease? Increase. अब ज्यादा फोर्स दे रहे हो तो ये ज्यादा वेलोसिटी से मूव होने लग जाएगा. ठीक है? अब कम फोर्स अप्लाई करोगे कम इससे बेसिकली इससे आप कौन सा प्रोपोर्शनलिटी बोलोगे? इसे डायरेक्टली प्रोपोर्शनल और इनडायरेक्टली प्रोपोर्शनल? डायरेक्ट प्रोपोर्शनल, right? So he says that this external force, let's call this external unbalanced force as F. Okay? That was directly proportional. That was directly proportional to the change that I was seeing in momentum. Okay? That was directly proportional to the change in momentum. So this was final momentum. This was initial momentum. Here minus here there was change in momentum. And how much time does it take for this change? That was also a crucial factor. So how much time does it take for this crucial factor? So I'll just divide it by t. So no wait, I'll just start again. So yeah, sorry. All right. Let me just put it properly. So F is directly proportional to, let me just write first. I see change in momentum. So change in momentum, and in how much time does it take? How much time does it take to reach this much velocity? So that time factor upon time. Okay, and since I know if this, let's say earlier if the speed was 0 and then it starts moving, the same body starts moving with 5 meter per second, then this body was of 2 kg, 2 kg. What was the initial momentum? Mass into velocity. So I am just representing u. आपको पता है u क्या है? Initial velocity हमने पिछले चैप्टर में किया है. U represents initial velocity. So u letter I am using again over here, and here I will use what? This is final velocity after applying force. I see that it is moving at 5 meter per second. So this is v. Okay. So u is equal to rest. V is equal to 5. How much is the change in momentum? You tell me what is momentum at this point?
0.
0. What is momentum at this point? 5 to 10, na?
10 kg
10 kg meter per second. All right. Okay. So how much is the change in momentum? Final minus initial. Okay. So how do I represent this change in momentum? Shall I erase this diagram? If you want, you can tell me. I'll redraw this again. So this is given by change in momentum. कैसे लिखेंगे मैं? TL final momentum minus initial momentum upon time. You know what is formula for momentum? It is mass into velocity. So final velocity is represented by v. Mass to change हो नहीं रहा तो m ही रहेगा यहाँ पे भी, and it becomes u initial velocity upon time. Let's take mm common. बचा के अंदर v minus u upon t. You know what is this, right? What is it?
velocity.
Change in velocity upon time means what? Acceleration. So I can substitute this as acceleration. So I see that external force is equal to mass into acceleration. This is very important derivation. We use this relation, force is equal to mass into acceleration, everywhere. Since you have now studied that force is given by what? Mass into acceleration. How did we come to this conclusion? Using the second law, Newton's second law of motion, we come to this very important conclusion. Okay? So by diagram you can show that this body was already, let's say, moving with velocity initially u. Okay? This body was moving with its velocity u. Then some external force was applied. Let's just write this. This was already moving with velocity u. Initial velocity of this body is u, and then it starts moving with final velocity over here. I see that its final velocity is v. And how much time does it take? I am using the letter t, so time taken for this change to be seen is t. So we come to this very important derivation. Now, when you change from proportionality sign to equal to sign, if you have done in mathematics, you will realize that you have to keep these things as it is, but then since you are moving from direct proportionality to equal to sign, there is some constant of proportionality. Mostly we use C letter. I don't know. Direct indirect variation आपने किया है mathematics में? Okay. So we use constant of proportionality. I do we have to put this? I'll give you one example. I will give you one simple example for the understand. Let's say दो चीज change कर रहे हैं, ठीक है? Direct proportionality क्या होता है? जब एक चीज बढ़ रही है तो दूसरा भी बढ़ रहा है, ठीक है? So let's say time taken distance ना, एक कार का टाइम कितना ले रहा है, डिस्टेंस कितना ट्रैवल कर रहा है, मैं ये रिलेशन प्लॉट करना चाहिए। सो अगर वो 1 सेकेंड में लेट्स से वो कितना कवर कर रहा है, 2 मीटर्स कवर कर रहा है गाड़ी, ठीक है। 2 सेकेंड में कितना कवर करेगा वो, 4 मीटर, ये आपको पता ही है बिकॉज़ शायद आपको रिलेशन ही समझ आ गया है। फिर 3 सेकंड्स में कितना कवर करेगा, 6। 4 सेकंड में कितना कवर करेगा, 8 मीटर, ठीक है। सो यू if you check, you see that this T and D are directly proportional. As T increases, and write down this side. As T increases, you know that distance value will also increase. So T is directly proportional to T. Okay. And if I give this T by D, or let's so you know what is D by D, let's do that. So if I put this T on this side, I see that D by D का वैल्यू हमेशा क्या आ रहा है, 2/1 क्या हो रहा है, 4/2 क्या आ रहा है, 6/3 क्या आ रहा है, 8/4 क्या आ रहा है, ठीक है। सो आप ये दो क्वांटिटी को डिवाइड करोगे तो आपको एक कांस्टेंट वैल्यू आती है, आप उसको बोलते हैं कांस्टेंट ऑफ प्रोपोर्शनैलिटी। क्या बोलते हो आप, कांस्टेंट ऑफ प्रोपोर्शनैलिटी। एंड दिस केस वी नेम दैट कांस्टेंट एज व्हाट, speed, right? Remember similarly in this case these are the two quantities that we are plotting. This is, let's say, this part, and this is this part, okay? So when we divide this upon this, I should get equal to के बाद मुझे constant value, ठीक है। ये जैसे c मुझे मिला था, यहाँ पे constant value आती है। So यहाँ पे हम वो constant value यहाँ लिख देते हैं कि आपको constant value आ रही है, ठीक है। आप जब प्रोपोर्शनैलिटी को इक्वल टू में कन्वर्ट करते हो, सो देयर इज वन कांस्टेंट ऑफ प्रोपोर्शनैलिटी। इट्स अप टू यू व्हाट लेटर यू वांट टू यूज। हियर रिप्रेजेंटेशन इज डन बाय दिस लेटर k, ठीक है। देयर इज दिस, ठीक है। सो हाउ डिड वी गेट सीधा f इज इक्वल टू ma? I told you it is very important, ठीक है। सो like here you saw that you took the values, you calculated them and you checked कि अच्छा हर बार ही कर रही हूँ तो मैं मुझे वैल्यू क्या आ रही है, 2 आ रही है। So experimentally they also did this, हर बार ही फोर्स अप्लाई करें, उन्हें पता है कितना फोर्स अप्लाई करें, चेक करें कि चेंज इन मोमेंटम टाइम लेकर जो है ये कांस्टेंट प्रोपोर्शनैलिटी का वैल्यू क्या आता है, and they check that k value comes to be around what, 1. If this k is 1, that means force is equal to what, mass into acceleration. Are you getting what I'm trying to say? ठीक है। So force is directly proportional to change in momentum upon time. This is 9th grade, right? And when you are removing this proportionality sign, you add the constant factor, okay, apart from what was there. यहाँ पे जैसे d था और t था, आपने उनके साथ कोई छेड़खानी नहीं की, so ये रहेगा। And since आप डायरेक्ट प्रोपोर्शनल इक्वल टू करें तो आपको एक कांस्टेंट प्रोपोर्शनैलिटी जो नया फैक्टर आता है, जो हमने नया लाया है, ये दोनों के अलावा था, आप वो ला देते हो। समझ रहा है, राइट? वी हैव टेकन वन एग्जांपल फॉर दैट एंड यू जस्ट पुट दैट टुवर्ड्स द एंड एंड you then have to say that experimentally we have found that k is equal to what, 1, ठीक है। That is why we get सॉरी, ओके, कांस्टेंट का मतलब क्या होता है, रिमेन्स सेम। यहाँ पे हमारा स्पीड क्या आ रहा था, कांस्टेंट आ रहा था, राइट? इस पर्टिकुलर केस में जो मैं प्लॉट कर रही थी t और t का वैल्यू क्या कांस्टेंट आ रहा था, राइट? हमेशा यहाँ पे भी ये दो चीजों का जो कांस्टेंट आएगा वो कांस्टेंट ही आएगा हर बार, राइट? तो वो हमेशा कांस्टेंट होगा, इसलिए मैंने फिर फाइनल जो मेरा फॉर्मूला क्या है, f is equal to m, ठीक है। So once I found the constant का वैल्यू, अगर आपको कांस्टेंट का वैल्यू मान लीजिए आपने सॉल्व किया तो आपको कांस्टेंट का वैल्यू हाफ आता, तो ये नया फॉर्मूला कैसे नजर आता, ma/2, हमेशा ये 2 फैक्टर रहता है इसमें, ठीक है। और यहाँ में कांस्टेंट का वैल्यू क्या आ गया, k। सो अभी हमारा क्या बन गया, f is equal to ma, ठीक है। I think they have even told you how to find this unit of k, and ठीक है, you're lucky they have not asked you. So k is nothing but आपको पता है what is k, constant of proportionality. They have not 9th grade 8th grade में ग्रेविटेशन चैप्टर हुआ है आपका? नहीं हुआ? जब आप प्लीज याद रखिए, जब आप ये प्रोपोर्शनैलिटी साइन को चेंज कर इक्वेशन के फॉर्म में कर रहे हो तो आपको वो कांस्टेंट फैक्टर ऐड करना पड़ता है। यहाँ पे मैंने के लेटर यूज किया। आप जब ग्रेविटेशनल फोर्स यूज करेंगे तो कैपिटल जी कांस्टेंट फैक्टर डालते हो, कैपिटल जी, ठीक है? सो इट विल ऑलवेज कम। सो this is new for the first time it is happening, but now remember henceforth you will be using this, and you don't have to worry about इसके यूनिट्स वगैरह आपको नहीं दे रहे हैं वो, वरना ग्रेविटेशनल फोर्स में वो आपको उस कांस्टेंट वाले यूनिट्स चला दो, यहाँ नहीं है स्क्वायर मार्कर, बट सिंपली मेंशन व्हाट इज के। यहाँ पे के क्या है? के इज कांस्टेंट ऑफ proportionality. Constant is spelling C. Is constant. It's T. STAND constant of proportionality. Now, using the given information, और आपको भी पता चल गया हम एसआई यूनिट कैसे निकालते हैं। यहाँ हमने एसआई यूनिट मोमेंटम का निकाला रखा है केजी मीटर पर सेकंड। आप लोग प्लीज ट्राई करिए एसआई यूनिट ऑफ फोर्स क्या होगा। डोंट ड्रॉ दिस टेबल, दिस इज जस्ट फॉर अंडरस्टैंडिंग पर्पस, ओके? First write what is momentum, what is SI unit for momentum, okay? And then Newton second law of motion. So should I erase this momentum part? Is this done? So next question I asked you that since you have now got the relation for force, force is equal to what? Mass into acceleration. Force is equal to what? Mass into acceleration. Give me SI unit for force. SI unit of force. So yes, mass is in terms of what? kg. Acceleration is what? Meter per second square. Meter per second square. ठीक है? So SI unit of force is kg meter per second square. But since we have got Newton who gave this whole relation, who gave this equation for force, we have a new representation for this. This whole thing is written as Newton. How is it written? Newton के इसमें so 5 Newton और 4 Newton. Of course, when we are writing the whole name of the unit, we write it in small. And इसका representation क्या? करोगे by letter N, and N stands for what? And what is the relation? 1 kg meter per second square is equal to 1 Newton. ठीक है? ठीक है? So SI unit of force क्या? ठीक है? SI unit of force. Let's do some presentation, some numerics. If you do not have the book, I'll give you question by reading. If you are done, let me know. The most important relation of this chapter is the second law of physics. Yeah, it's the most important. And then we have the important variables based on it. Are we done? Yes. Okay. Before we start with numerical, I'll just tell you what all we missed for this. I told you that inertia एक छोटा सा part रह गया था. Yes. So how to say second law बोल लेते हैं ठीक है फिर मैं second inertia पे आती हूँ. How to try it? Let's put it in your textbook way. So when we were doing speed is equal to what d by t upon t होता था. So आपको वो define करना था तो आप कौन सा word use करते थे? Rate at which distance? Rate at which distance is covered? Or not? We did speed velocity in this class, right? So how do we define speed? Rate at which distance is covered, and how it is displacement? Rate at which displacement. Speed is rate at which distance is covered, and velocity is rate of change of displacement. So upon time जो है उसलिए हम rate word use कर रहे हैं. So यहाँ पे भी upon time है, change in momentum upon time, ठीक है? So यहाँ पे हम कैसे बोलेंगे? Rate of change of momentum, ठीक है? So right, second law of Newton's second law of motion. Newton's second law of motion. Newton's second law of motion. Newton's law of motion states that upon time है यहाँ पे. So what will be the starting point? States that the rate of change of momentum, the rate of change of momentum of a body or of an object, whatever you want to say. The rate of change of momentum. You just reframe everything this which is given mathematically. So rate of change of momentum of a body or of an object. What do you see is directly proportional, right? It is directly proportional, right? Is directly proportional. And what does F represents here? Which force? External unbalanced force is directly proportional to the, यहाँ टेक्स्ट में लिखा है applied unbalanced force. Basically क्या आप apply करें external force apply. So आप टेक्स्ट के वर्ड्स लिखिए to the applied, but what is important? Unbalanced force. ठीक है? So external unbalanced force बोलिए या applied unbalanced force बोलिए. Are you getting? How we are just reframing this in English. ठीक है? So rate of change of momentum of an object is directly proportional to the force applied. And how is this force? External unbalanced force applied on the object. Okay, that's it. Now the thing that I missed. Inertia है. Inertia का body is what? Tendency to resist उसका जो भी state का motion है जो रुका हुआ है तो रुका हुआ है. So this depends on something. ठीक है? ये जो tendency resist करने की tendency है ना, किस पे depend करता है? Object के mass पे depend करता है. किस पे depend करता है? ऑब्जेक्ट के मास कोई जा रही है, ठीक है, बहुत हैवी चीज जा रही है, ठीक है, मूव हो रही है, ड्यू टू उसके पास वो इनर्शिया कैपेसिटी एक बार धक्का दे दे तो आपको पता है वो जाने ही वाला है, प्रोवाइड फ्रिक्शन भी बहुत कम है, ठीक है। रियल के सिनेरियो मूव हो रहा है और आपको अपोज करना है इस फोर्स को, तो आपको उसको रुकाना बहुत मुश्किल लगेगा, बट आप लोग मार्बल है और एक मार्बल जा रहा है उसको रुकाना है तो क्या होगा, आसान होगा, ठीक है। एक बहुत बड़ा बोल्डर जा रहा है, तो why is it difficult to stop that? Because it has huge inertia of motion. इसका inertia जो इतना huge है, because इसका mass भी बहुत ज्यादा है. So what is inertia जो यहाँ पे, ये this is dependent on what mass of the object, ठीक है. So mass ज्यादा है, तो उसकी tendency to resist भी क्या हो सकती है, ज्यादा हो जाता है, ठीक है. So आपको यहाँ आपको जो भी केस सिनेरियो दिया है, आप ही मुझे बताइए आंसर क्या होगा, आपको समझ सकता है रिलेशन क्या है. So first question is, which of the following has more inertia? First question. Don't write it. This is very easy. लिखना भी नहीं पड़ेगा. Which of the following has more inertia? A rubber ball and a stone of same size. Which one has more inertia? A rubber ball or a stone of same size? रबर बॉल है, रबर बॉल है और एक स्टोन है, दोनों सेम साइज के, दोनों भी राउंड है, दोनों भी सेम डायमेंशन है, बट ऑफ कोर्स किसका वजन ज्यादा होगा आपको पता है, स्टोन का, किसका इनर्शिया ज्यादा है. नाउ द सेकंड वन इज अ बाइसाइकिल एंड अ ट्रेन. तो चलती हुई ट्रेन को रुकाना हम तो छोड़िए, काफी मुश्किल हो, बस को आप शायद 5-6 जन नीचे गिरते हैं, ऐसे सीना था ना मूवीज में, नीचे गिर रही है बस, रुका दिया, 5-6 जन धक्का मार रहे, ट्रेन हाँ नहीं गिर गई. The last one is a 5 rupee coin and a 1 rupee coin. ठीक है, 5 rupee coin. So this is not important. There's only to write that between and this is small part. ये भी बहुत I don't know. Let's discuss part. In the following example, try to identify the number of times velocity of the ball changes. Scenario बता रही हूँ, पर आपको बताना है कि velocity जो है कब कब change होती है. Scenario है, a football player kicks a football to another player of his team. So, a football player kicks a football to another player of his team. Who kicks the football towards the goal? Okay. Who kicks the football towards goal? The goalkeeper of the opposite team. That's it. The goal player of the opposite team collects the football. He is the goalkeeper, so he collects the ball, okay, and kicks towards the player of his own team. And kicks towards the player of his own team. Scenario समझ आ गया, बड़ा easy scenario. मैंने यहाँ से बॉल पास किया, मैंने वहाँ से पास किया, गोल की तरफ, गोल हो गया, गोल हो गया. आपने वो बॉल कलेक्ट किया, ठीक है, नहीं भी क्या होगा, गोल हुआ नहीं दस मिनट. आपने वो बॉल कलेक्ट किया, देन आपने वो बॉल को यहाँ आपके टीम प्लेयर को पास कर दिया. तो आपको बताना है, try to identify the number of time the ball velocity changes. बताइए चलिए. One time, 2 times, 3 times he stops, and 4 times he passes. 4 times. One, two, 1, 2, ठीक है, अब वो उससे बॉल उठाया भी ना, ठीक है, तो 3 and then वो finally अपने प्लेयर पर लेगा तो 4, right? 4 cases है. Now the next question is also identify the agent supplying the force in each case. So हर केस में who are the agents who are applying the force? So first case में तो कौन पहले force apply किया, second में कौन है इन्होंने apply किया, third case में कौन है Swan has applied, fourth case में कौन है, who is fourth case में भी Swan है, third case में Swan बॉल उठाता है या कलेक्ट करता है, और फोर्थ केस में Swan Well, okay, that's the third and fourth case में he is the one who's applying forces. ठीक है? And first and second में ये. I think it's very easy question. ठीक है ना, समझ गया? तो ये first second है. Let's now go to numerical part, which I said we have now reduced one relation S which is given to us. We have got the new term. We have got the new term called momentum. And what is momentum? Momentum of any body is given by what?
Mass,
mv, the fixed mass, and the velocity that it is having. Okay? The second important relation is actually the most important relation that we get by a second law of Newton's is, what is the relation? Force is equal to rate of change of momentum, and if we do all the v minus u upon v into m, we get force is equal to ma. So force is equal to mass into acceleration. It's the second most important relation. Now take a numerical for that. Let's see how much time do we have.
10 minutes.
So I think we can solve at least one or two numerical. So let's try to do any one of that. I quickly write the question for you. Okay. An object of mass 100 kg, an object of mass 100 kg, an object of mass 100 kg is accelerated uniformly, from a velocity of 5 meter per second. This is 5, okay, not 6. This 5 meter per second to 8 meter per second in 6 seconds. So आप मुझे इसमें 3 चीज बताएंगे. First, what is the initial momentum? Initial momentum. Of course, what will be the second one? What is the final momentum? The third one, आपने ये जो चेंज किया है ऑब्जेक्ट जो 5 मीटर से 8 मीटर से चेंज हुआ है, उसके लिए आपने कितना फोर्स अप्लाई किया है? फोर्स अप्लाई. ठीक है? These are the 3 things. Quickly give me answer for this. It is straightforward. Straightforward application of the formula, and all of the units are all units are in SI unit, so there is no conversion also to be done. So it is pretty straightforward. So what is the first answer? Initial momentum कितना होगा? 500 होगा. This is mass and this is the initial velocity. So 500 units क्या है? kg meter per second. ठीक है? So initial momentum I can simply write mass into u. मैं just simply यहाँ लिख दे रही हूँ mu. ठीक है? और आप लिख दीजिए 100 into 5, which is equal to 500 kg meter per second. Similarly, final momentum will be given by mv, which is 100 into क्या है आंसर? 800, right? It's very straightforward. And of course, force क्या होगा? Force is how much? It is given by what formula? Either आप इसके terms में लिख सकते हो आप या change in momentum के terms में लिख सकते हो. आपकी मर्जी है. So आप चाहो तो mv minus mu upon t लिखिए. It's up to you. We already know, right? It is nothing but change in momentum. So change in momentum की value क्या है? 800 minus 500. 800 minus 500 upon time taken. How much time is taken? 6. So how much is this? 300 by 6. And what is the SI unit? Because everything is happening in SI. So force का SI unit क्या है? That is very important. Please put the units. This is the first numerical. Please pick this question. Let's take this question. Okay. Shall I take the question? Okay, the question is that automobile vehicle, an automobile vehicle has a mass of, so mass of that vehicle, you can put it in that also. An automobile vehicle has a mass of 1500 kg, 1500 kg. What must be the force? What must be the force between the vehicle and road if the vehicle is to be stopped? If the vehicle is to be stopped, if the vehicle is to be stopped with a negative acceleration, of 1.7 meter per second square. 1.7 meter per second square. चलिए बताइए सबसे इजीएस्ट क्वेश्चन है. How much is the mass of this body? This is the most easiest one. Can you tell me what are they asking you to find? Force. So always write the given information. At times question पढ़ के समझ नहीं आता, but once you put the information आपको समझ आ जाएगा कि आपको क्या यूज करना है. What formula will you use? X is equal to ma. ठीक है, मेरे पास मास भी, मेरे पास एक्सेलरेशन भी है, मुझे सिर्फ फोर्स ढूंढना है. So force is given by what? ma. ठीक है. So mass is 1500 and minus 1.7. ठीक है. So what is the answer you said? ये 15 17 और 15 हमारा आ जाएगा 0. So 17 15 7 is 5 7 8 9 10 550. Here we are matching, and unit of course would be what? Newton. Oh, Newton. And I put SI unit in Newton. Don't put so the easiest one, straightforward application of the formula. Now, let's take another. How much time do we have? 5 minutes. Well, let's say this verbal question. Now, you will tell me, okay? Why is it advised to tie any luggage kept on the roof of the bus with rope? So what will happen if it is not tied? You will have to say that, right? Call up when if the brakes are applied. So if the brakes are applied, if the object is not tight due to inertia of motion, it will go ahead and fall down of the vehicle, just fall down of the vehicle and get damaged. Correct? That is when you need to tie. When a carpet is beaten with stick, dust comes out of it. Explain. Again. Is because of the inertia and how it explains. How will it explain? Yes. How will it explain? आपके पास carpet है, आपने छत से मारा, what is going to happen? Dust. The dust will what? आपने जब उसको झटक के मारा होता है, ठीक है? So ये जो carpet होती है ना, carpet का mass क्या होता है? ज़्यादा होता है, but dust जो होती है उसके ऊपर, उसका mass ज़्यादा होता है? नहीं होता है, right? जब आप मारोगे, ठीक है? So dust तो ज़्यादा उड़कर आ जाएगा, but carpet जो है हल्का सा change आता है, because उसका inertia ज़्यादा है, तो वो इतना move नहीं होती है, but dust क्या होता है? ज़्यादा distance travel करेगा. Are you getting what I am trying to say? Because there is mass difference and dust are lighter particles. ठीक है? Carpet will not move to that extent, but dust will move by a greater extent, basically. In fact, there is another part called law, but हमने वो किया नहीं. So I can understand हम वो सारा detail में बता सकते हैं, but थोड़ा part आपको समझा? यहाँ पे mass का relation, हमें पता है inertia और mass का relation. Let me see. What is momentum of an object? There are 4 options, and I believe you all know what is momentum of an object's formula.
The product of mass.
Mass into velocity. Here 4 options are there: m square, v square, nv square, half mv square, and mv. So it is mv. So that's all our momentum. I believe we have to discuss them. Next class, do bring textbook and do bring your volume so that we can discuss full part यहाँ पर रह गया है. An object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with non-zero velocity? This is a question. An object experiences a net zero external unbalanced force. So we discussed this. But then what is your answer, sir? The question is, एक object है, उसपे first order मैंने properly दिया है, external unbalanced force act हो रहा है. So there is an external unbalanced force and एक extra information है a net zero. ठीक है? Is it possible for the object to be traveling with non-zero velocity? We'll discuss it next one because this will take time. I will again have to go through that zero and original unbalance. So are we meeting tomorrow? Then we can finish this chapter. Yeah, we can next class.